This is the first question of assignment 2, which is to implement an undo redo application. The first two classes are to implement the doubly linked list, which is basically the same as the source code given by modulus 4. And I did make some little change to the inner structure of doubly linked list, but basically nothing different with the functionality. Here is the undo redo class. It basically have the following functionalities. The first one is do, which is to make some change, do some actions to the list of the class. Oh, by the way, first one, this is the constructor of the class, which is to accept a list and save that into the class. And the class is going to initialize a data structure of the doubly linked list, which is going to save the states of the list, and that is going to support the undo and redo functions of this of the application. So now the do this method, the do method is to perform changes, perform actions to the list. So basically what it accepts is the data parameter, which is a string describing exactly what should be done to the list. And here then it is being executed by interpret the information stored in the string and do the corresponding change to the list. And while that was happening, the state of the list is being stored in the doubly linked list in this class. And here the undo method is just to return the current state to the previous state in the doubly linked list. The redo method is to move from the current state to the next state, which is should be the previous state before the undo method. And I also have this current state method, which is just to return the current stored the data stored in the current state of this class. And lastly, I also implemented this print current state method, which is just to help make it easier to print out what is the current state of the list. And here is what this application will do. So firstly, I will define a list with 5, 3, 2, 1, 4, 8. So I initialize this list, and then I initialize the undo, redo. I store the list into this structure, and right now the list in the structure is going to be here. So just as I inputted into the class is 5, 3, 2, 1, 4, 8 stored in the, that will be the original state and the current state of the list. So now I want to apply sort to the list. So what I do is that I call the do method, and then with the sort application in that, and then I also print out the current state. As we can see, the numbers stored in the list are already being sorted by this do method. And next, I want to reverse the current state, reverse the order of the numbers in the list. So I call the do method again. As we can see now, the all of the numbers are sorted in a descendant order. And now, next, I want to append number 9 to the list. So this is the current state of the list. And next, I want to undo the last. And now the last store, number 9 just appended to the list is being undoed. And I want to undo again. Then I just go back to the state where I have not sorted the list. And if I'm doing redo, then now, yeah, the list is being reversed to the state previous to the last undo. So that's basically all of the functionality I implemented for this undo redo application. So the second question is to implement a stack data structure and use that to determine whether a word is a palindrome or not. So the implementation for the stack structure is pretty straightforward. Just use the doubly linked list to implement the functionality. This one is to check whether the stack is empty. This one is a peek, which is to return the last item in the doubly linked list. And this one is the pop method, which just to remove the last one. And the push method is to append the data to the last one in the currently doubly linked list. And this is a function I used to determine whether a string is a palindrome or not. It's pretty simple. So basically, firstly, I calculate the length of the word, and then I'm going to store the first half of the word into the stack. So I'm using the push method of the stack to do that. And then if this one, in this line, I'm calculating whether the current, calculating the start integer for the pointer for the next number. This is, here I'm using the ceiling method because I want to calculate this number based on whether the length of the word is an odd number or even number. And then I start to just counting, moving the pointer from start to the end of this of the string. And every time I do that, I pop one character out of the stack. If these two characters match, then so far so good. And if I successfully reach the end of the word, then the current word is a palindrome. If not, if everything is wrong in the middle, then this one is not a palindrome. So here I'm these few lines is just to read the word in this text file and to determine whether each one is a palindrome or not. And I'm going to show the here is a result of this check of this stack structure and how I'm checking whether each word is a palindrome or not. So as you can see, all of the words read from this word list, from this file. Among that, the morning, the first word morning is not a palindrome, level is a palindrome, and so on. So as we can see, this method is successfully determining whether a word is a palindrome or not.